Over the course of about 20 years, Panda3D has changed around how we import the showbase. The showbase is the set of logic that describes the scene graph, which is a wonderfully useful tool for imagining scenes in 4 dimensions. I will try to show a minimal way and a modern way to import the Panda3D engine and really start to work with it without a lot of setup. It's actually sort of difficult to piece together all of the admittedly very good snippets from the manual on Panda3D's website. And this way we can sort of speed up that process by showing what, after many years of working with Panda3D, what I like to use as a minimal framework when I'm thinking about a brand new idea. We begin with some imports that might seem a little new to people who used Panda3D years ago. Not random, of course, that's one of my favorites, but simple PBR, which is a physically based renderer add-on that replaces the set shader auto function that was used for, I believe, many years inside of the render part of the engine, and also GLTF, which is a format that Blender 2.9 can export natively to, which is really good for maintainability. And for older Panda3D users, is a replacement for Yabby, which is the bolt-on Blender exporter that is broken as of, I believe, 2.8. So we begin by declaring our main class, and we put a showbase object inside of that. We have a regular initDef in self space. And then we're going to go ahead and load our PRC file data, and I don't have a lot of it for this minimal sample, so we're just going to load it in line so we can read it more easily. Framebuffer-srgb forces the color profile of textures in the frame buffer, which is useful when you're using PBR. And then load PRC file data just to get a window size of 1200 by 700 for prototyping. So now we get into our new initialization routine, which is what I'm using as of late 2020. So we call super on init, and we're doing that instead of showbase, which was how I did it for years. Then we're going to call simple pbr.init to get our physically based renderer going. And that replaces set shader auto, which still works, but not with this particular way of initializing the showbase. And then we get our GLTF patch loader, which patches self.loader, so we can just keep using self.loader to load, let's say, models into the scene graph. Let's call an ambient light just to get a little ambient light on the renderer. Our first model is this Blender file, which is a cuboid, fairly high tessellation, and this is exported directly. We'll go ahead and set the position to some non-standard value for fun. The scale at 1. Then we'll get our spotlight going, which is the most sophisticated type of light inside of Panda3D. We'll set the color to white with an alpha of 1. We'll go ahead and set the shadow caster on, which works fine with everything. So the true, and then the resolution of the shadow map. The lens of the spotlight is a perspective lens, and we'll set that. We'll attach a new light node to the render space. We'll set the position of the node, and then we'll have the node look at the first model that we loaded in, and finally set the light inside of the renderer. This is some placeholder code that we'll load a texture onto a standard Panda3D model. We'll not use that right now. And these are one-line animation functions that use a lerp position HPR interval for the first model and a lerp position interval for the light node in order to give some basic animation on the objects so that we can see that our renderer is working correctly. We'll go ahead and set our camera at the current position in self.cam, not self.camera. We'll have the camera look at the first model. And this code right here makes me want to weep with its minimalism and beauty, because in any other game engine that would be a lot harder to do in raw code. But we're merely telling the camera to look at this first model that we just loaded in with 4 lines, which wholly describe quite a lot of it. And now we'll load in our excellent physics environment, which is bullet physics with Python bindings. And the task system is actually a highly sophisticated and advanced system for managing virtually everything in your game logic inside of Panda3D. So we'll go ahead and define this task. We'll put task inside of the function input. We'll do something, which is make the light node track the model, and then we'll return task.cont with no extras here. There's no functional notation here, just task.cont, which is continue the task, please. Then we'll add this task to the task manager. We'll define our application as the main function, and then we'll run the special code, which is app.run. And that wholly defines our Python file. So we'll go ahead and do the fun part and run the program. So it looks like our animation system is working. The light and the object are moving. It looks like our lighting and shadow mapping is working appropriately. And although those animation lines are extremely succinct, it's amazing just how much we can really see going on here with these 2 interacting objects.